Yes. Okay, it's 3 o'clock. Let's go ahead and get started. If I could call your attention to the front here. It's my very great pleasure to introduce Duncan Agnew today, who's going to be telling us a little bit about some history of IGPP. So Duncan is not just an expert researcher in crustal deformation being measured using GPS and strain meters, the Earth and ocean tides and time series analysis, but he's also very knowledgeable about the history of science and seismology and geodesy in particular. And he also knows a lot about IGPP. He got his PhD here in 1979 and has been a geophysical researcher and a professor here since then. So very much looking forward to hearing from him about the history of IGPP. Duncan, over to you.
Okay, so this is, first of all, tell me if I'm not adequately audible. I have here some early history of IGPP. The sum is because, like any history, this is incomplete. And the early is because I think it's more obscure. How did IGPP come to be? I won't completely end with the start of IGPP with in 1960, the building of the building in 1964, but I'll end pretty much there with a little bit of an afterpiece. So, my subtitle is Organization, Vision, Building, and Science. That is, how did this get organized? What did the people who organized it think they were doing? How did we get a building? And what science got done? So I'm going to start in what may seem like an unusual place. That's Leipzig, 1911 to 1913. 1911, Wilhelm Bjerknes, Norwegian meteorologist, was called, that's the term in German academia, called to a professorship, the professorship. And he beat out Alfred Wegener. And in 1913, he was given an Institute of Geophysics. So I start here because this is getting to the root of why is IGPP an institute? What is that about? Well, in the German university system of the time, if you had a department, there was a professor. Okay, there was only one, and he was and there were two kinds of professors. Yes, I look for corrections from the experts here. Be asking you for something in the next professors, just regular professors, and then there were professors who had an institute. And what was an institute? Well, an institute meant that you had talked the authorities into providing you with money. You have a budget. You had a lab. If you were a regular professor, you just lectured in the lecture halls. If you had a seminar, the students came to your house. If you had an institute, then the institute had a budget. Maybe you'd have your own building, people, equipment, whatever. And to pay for publication, you could also publish your own, very own. So I am looking to Elise to tell me what the first word means here. Publications of the Geophysical Institute of the University of Leipzig from the director Wilhelm Bjerknes. So this is the sort of thing you could do. You could have your very own publication series because you had an institute.
Sorry.
All right. So now I can't advance. Yep, there we go.
Good.
So this is an example of the kind of building you might get. This was not what Bjerknes got. This is the kind of building you got if you were in a German university in Strasbourg, which was in a German university because Germany had won the Franco-Prussian War and taken Alsace-Lorraine away from the French. And so they were going to show the French how you built a university, by God. So this was the Kaiser Wilhelm, it's not called that anymore, Physical Institute at the University of, well, you can choose the spelling as you like. there actually is at Strasbourg a museum of seismology, which is in the original seismology building, which is also quite an elaborate structure, but it's mostly sunk in the ground. So it's not very interesting to look at. It looks like someplace you, I don't know, store cheese or something like that. But anyway, so, but you might end up with a building like this. So what happens next? Well, so in 1917, Wilhelm Bjerknes, with his son and collaborator, there's forgotten the last first name, Jack Bjerknes, I'll call him that, moved to Bergen, where he has a professorship and an Institute of Geophysics. So that's the Institute of Geophysics that in some ways becomes our parent, because in 1926, he moves to Oslo and his former student, Harald Sverdrup, becomes a professor at Bergen at the Institute of Geophysics. In 1936, Sverdrup becomes the director of Scripps. And in 1940, Germany invades Norway. And Sverdrup, Jack Bjerknes, who was actually at the airport when this happened, ready to go home, and Jay Holmboth, so 3 Norwegians, are now all at UCLA for the duration. Scripps, by the way, was an arm of UCLA at this time. That was, the University of California consisted of Berkeley and UCLA, which had been formed over the dead bodies of a lot of people at Berkeley who didn't think there should be a second campus. So here are the people behind the Institute of Geophysics. Jack Bjerknes, professor at UCLA, Harald Sverdrup, director of SIO, pictured in color here in front of the old Scripps building, and a fellow named Joe Kaplan, who was the chair of physics at UCLA, and then I give him as the head of the Office of Prediction and Analysis section of the Weather Ring of the US Army Air Force. Because reading through the files, it's pretty clear this was the kind of academic who discovered in World War II that he really liked running large organizations. And so he was a bit of an empire builder. So what did they do? Well, in 1944, people were starting to say, well, when the war is over, what sorts of things do we want to do? And so they wrote a memo saying we should have an Institute of Geophysics for the exploration of the Pacific, which then got changed to with emphasis on problems of the Pacific, and goes on to say there's research in geophysics at the departments of meteorology, physics, and geology at UCLA, and at Scripps, the IG, and then crossed out is IGPP, Institute of Geophysics for the Exploration of the Pacific. Shall coordinate such research, become a West Coast research center concerned with various problems, shall be established by the University of California, which shall provide space for offices and laboratories and a permanent staff of scientific and technical personnel. It is hoped that the Institute will also obtain federal funds for projects of national interest. People can see that one coming too. So what happened as a result? Well, they were successful. In 1946, the president of the University of California recommended that an Institute of Geophysics be established with headquarters on the Los Angeles campus and with research as its primary function. I emphasize that because, of course, this was a novelty at the time, as opposed to just teaching. And then saying geophysics embraces physics of the atmosphere, of the ocean, and of the solid earth. So there was an Institute of Geophysics, and the next question was, well, who's gonna run the place? Sorry, but before I get to that, there's two things that happen. One is a thing that doesn't happen. During World War II, Point Loma housed the University of California Division of War Research, UCBWR, which did acoustics. And with the end of the war, the question was, well, what do we do with these guys? How do we fold them back into the university? And it was suggested that the new group in sonar research could properly be fitted into the university by being part of the new Institute of Geophysics. The main reason for suggesting this is that the contemplated group will be heterogeneous, comprising physicists, mathematicians, and engineers. So this was a memo on relationship between the Institute of Geophysics and the Point Loma group. This didn't happen. Instead, the Point Loma group became MPL. Something that did happen was of great consequence. It is recommended that Mr. Walter Munk be appointed assistant professor at the Institute of Geophysics. It is proposed that 1/3 of his salary be charged to the Institute of Geophysics, and the remaining part is charged to contract funds. So you get 33% hard money support. And quite impressively, this recommendation was made before he got his PhD. We don't do it like that anymore. And here is a picture of Walter, presumably on PhD day with Harold Sverdrup. And I like to refer to this as goofy guys in funny hats. I really like that photo. Hopefully, it's been suggested this should perhaps take the place of one of the existing door photos, and I'll get to door photos in a little bit. But for the Institute of Geophysics, the first director of which remember was at UCLA, was Louis Schlichter, who was a geophysicist at the University of Wisconsin. And it's complicated. He was hired to come to UCLA, then he went back to Wisconsin. They hired him again. And remember, the people who started the Institute of Geophysics were oceanographers and meteorologists. And so Schlichter was the solid earth geophysicist in the group. And so he's the one who brought solid earth geophysics to the Institute of Geophysics. Wasn't the only person doing it, as we will see. So what was the science that was going on at this time? What was Scripps doing in geophysics in the 1950s? Well, Russ Raitt was doing seismic refraction studies, the seafloor. Teddy Bullard, about whom I will say much more, was investigating heat flow. A fellow named Ron Mason from Imperial College was ended up towing magnetometers behind ships because, well, we don't know why we should do this, but we have a magnetometer, we have a ship. And he had a great deal of trouble understanding what he was seeing. Of course, it turned out to be magnetic anomalies. And Walter at this time was doing a number of things, but notably in solid earth geophysics, he was working on how the rotation of the Earth related to fluid motions in the atmosphere, the ocean, and the core. And a snapshot of this is given by a conference in 1952. So this is what were scientists doing? So you have Bob Dietz and Bill Menard reporting on bathymetry from one of the first of the Scripps expeditions. Russell Raitt, seismic studies of Bikini and Kwajalein atolls. These were not coincidentally places where people were detonating nuclear weapons. Two other people looking at heat flow. This was, I think, about the very strange optical things you see off the coast here still. This was Chip Cox doing roughness of the sea from sun glitter. And then Roger, Gordon Rose working on the effects of geophysical flows on Earth rotation. So that's a sort of a, as I say, this is kind of a snapshot of what were people do, if you did geophysics here in the 1950s, what were the kinds of things that people looked at? So here's another snapshot. In 1954, the Institute got 2/3 of its funding from the US Air Force. Almost 1/3 of its funding from the Office of Naval Research, and a tiny amount from the NSF. So this was largely an applied operation. It had 54 FTEs, which is kind of a lot. And 41 of those were funded from external funding. 13 involved state support. 6.9 of them were non-academic people at UCLA. 6 of them were faculty at UCLA. And 1/3 of them was a faculty member at Scripps, namely Walter. So you could see that most of the funding was going through UCLA. Scripps's part in the Institute of Geophysics was a pretty small one. So I've given you one sort of line of descent from the German university through Harold Sverdrup to there being an Institute of Geophysics. Now we come to another place which also had an influence, and this is Mattingly Rise. Mattingly Rise is, Guy can correct me, a large hill in Cambridge, probably 20 feet high. On top of which is this house where was housed the Department of Geodesy and Geophysics at Cambridge. This was run by Teddy Bullard, who fortunately I knew somewhat as a graduate student. This is Roger Revelle. This is Teddy. This is Albatross, which was given every year as an award by the American Miscellaneous Society. And the winner had to carry it home. So this was not Teddy in the 50s. This was a slightly later Teddy. He was a very, he had a lot of influence on how things were done. And one of the influences on him was he was a protege of Ernest Rutherford at the Cavendish Lab, one of the pioneering places for atomic physics. And Rutherford was described as having a buccaneering style, and so was Teddy. It was pretty much, okay, you want to do this? I'll find the money. You know, go ahead, I'll deal with the problems. And there was a strong, Teddy was very much an experimentalist, so that he was promoted the building of instruments and use of instruments in geophysics. There was another piece of Cambridge geophysics, which was the part that descended from George Howard Darwin. Yes, he was one of Charles Darwin's sons, who did mathematical geophysics in the 1880s through the early 1900s, followed by Harold Jeffreys. And they did mathematical modeling and very thorough data analysis. So Jeffreys, for example, was one of the producers of the first travel timetables for seismology, which involved looking at a vast amount of data, all of it processed by a hand crank calculator. So there's some styles of work that came from Cambridge, very much so. How did this get to Walter? Well, Walter had a sabbatical and spent it at Cambridge. And that's one piece. The other piece is Teddy Bullard basically came to La Jolla every summer as a visitor. And so he was very much a regular around Scripps starting in 1950. And so he had quite an influence. So Walter put forth an idea. I have become convinced that a modern scientific institution must have a broader base than that of the Scripps institution. So I think he felt that Scripps was too narrow, or perhaps too focused just on the ocean. And he worked on Earth rotation. He wanted to have a place where other people would work on a broader range of problems. And his specific proposal was to have an institute sufficiently small that its director could devote most of his time to teaching and research rather than administration, and sufficiently remote to provide peaceful intimacy among its members, which is something I think we have been very good. The last phrase here, I think we have been quite good at doing. You may wonder about the phrase remote, and I will try to justify that as I go along. Now, he put this forward in the context of an opportunity, which was that he had offers from Harvard and MIT. And as anyone familiar with the university system knows, the best way to get something is to threaten to leave. At least if people want to keep you. Roger Revell's response was, well, what can you do at Harvard that you couldn't do here? And UC was growing at a great rate, and the university, particularly its branch, which was, this is a little piece of history some will know and many won't, the University of California at La Jolla, which was its original name. Needless to say, when the city of San Diego got involved, it got changed to UC San Diego. So there was a lot, there was a new campus being built. Revell had been one of the leaders of that. So resources were coming in. A lot of people were being hired in a bunch of departments. It was relatively easy to get resources at the time. So it wasn't hard to persuade Walter to stay at Scripps and see what he could build here. Now, what does that mean? I mean, he was a third of an FTE. And IGP was, which is what it all was then, was run out of UCLA. So the first thing you need is autonomy. You need to have some level of control over what's going on here in La Jolla. You need resources, you need FTE from the university, you need other outside support. And ideally, you'd like to have your own building because Scripps was, as always, a bit cramped for space. For that, you need a place to build it, and then you also need the money to build it. So let me go into the autonomy part and the building part and a little bit about the resources. So the autonomy part, and this is one of those great discoveries in the archives that you make when you go looking. The autonomy part is documented in a series of 3 letters. First one is from the director, Louis Schlichter, to Walter, associate director at Scripps, saying $2,500 has been transferred from our Los Angeles appropriations to the Institute of Geophysics at La Jolla. Under the new procedure, the portion from La Jolla should be obtained from UCSD. In other words, we're not providing money anymore. Get it from the locals. So that's September. A month goes by. There's another letter. We have now moved up the academic chain to one chancellor to another chancellor. As a step in the decentralization of the institute, it would be appropriate for UCLA to transfer permanently to UCSD both FTE and funds to continue Dr. Munk's level of support. Namely, you want us to support him? Give us what you have. Well, I don't know what happened next, really. I only know the next document. This is from the president of the university. On December 28th, this was an era when the university did not close between Christmas and New Year's, but still. And it says, effective immediately, IGPP is to be decentralized. And the associate director will report to the chancellor at San Diego through the director, that is, Walter would write a report. It would go through Schlichter, but it would end up with it on the San Diego campus. So decentralization meant no, the La Jolla branch is no longer under the control of the Los Angeles branch. So I think this is very interesting. Admittedly, maybe you have to have spent way too much time at the University of California to really appreciate this kind of thing, but it's an interesting little bureaucratic infighting. So that took care of the autonomy problem. What about a building? Well, so in 1961, IGPP existed. There was more than just Walter here. It was housed in Sverdrup and Ritter. So what about a new building? And so this was a story Walter loved to tell. His system was to get the university to put up half. Then he got the Air Force to put up half of the remainder. Then he got the NSF to put up half of the remainder of that. Then he got the Fleischmann Foundation to put up half of what was left from that. Now we're down to 6%. And I don't know what got the last 6%, but he got there somehow. Maybe he didn't. We'll see that. So that took care of funding. So I want to go into perhaps too much detail about where the building was put, partly because I think it explains the rather unusual design of the IGPP building. When I first came, I kept feeling that there was something weird about the building. And I finally figured out that there aren't very many buildings where when you go from the first floor to the next floor down, or between floors, the direction of the hallway changes by 90 degrees. Okay, not many buildings have this two things at right angles feature. So IGPP, our current building, was built on the site of something called Community House. This was built as part of a summer program for teachers when they also built a number of the other cottages. It was a bigger one and had its own kitchen. It had a place for people to visit. And it was used sort of for visitors, including Walter when he first came here. Notice there's this, so it's out somewhere. There's a bridge, but you may be, and there's the old scripts here in the background, but you may be wondering, well, where is this exactly? So let me walk you through that. Here's a picture in 1967 after the building was built. Down here is the service yard, still unchanged. Then there's a parking lot, and there's the IGPP building. So let me zoom in a little bit. And you can see it a little better. And so, okay, this is pretty much what you had then. And I'll get back to the what was around it. But so what happens if we look much earlier? So this is the piece, this part you're familiar with. So this is 20 years earlier. Here is all of scripts. Down here, there's the pier, there's the same service yard. Over here, though, we'll see a sort of a canyon and a little white thing if we zoom in on that. This is the canyon, this is the bridge, here is Community House. So Community House, the picture I first showed was taken looking across the canyon at this slope with this house on top of it and a bridge. Here's biological grade, basically where it's always been. Here's the Rachel's Drive, which at that time had a slightly different routing. And so this is looking up biological grade at some time like this period. And there's the canyon, there's the bridge. And so that's what was there, was this ravine that emptied out, did a right angle and emptied out into the ocean. And this is a view looking the other way. So how was the building designed and built? Well, I will say that I think the right way to think about this is that the overall design of the building is due to some combination of Walter and Judy and Lloyd Rocco, who was a local San Diego architect who built quite a few things, though mostly houses, I mean private residences, was the one who turned it into an actual building. Now, the university posed some problems. And here again, these are favorite Walter stories. The first was, you're building on a cliff. The cliffs are unstable. Well, he got Francis Shepard out. Francis said, no, the cliffs are fine. Okay, you get your own local geologist. Okay, and you want to build it out of wood. Now, Lloyd Rocco liked to build out of wood, so that was part of it. And we only use wood for temporary buildings. Walter pointed out that he was about to replace a temporary building that had been there for 40 years. And so, okay, fine, declare it a temporary building, right? We still, the Martin Johnson House is a temporary building that's probably over 100 years old by now. So the fact that it's labeled temporary is not that big a deal. And the other argument was, no, this is too far away from the rest of Scripps. And that, of course, was part of what Walter was looking for. So, do to give you some sense of Lloyd Rocco's involvement, this is his own building built in 1949, called the Design Center, which was basically his architectural office. And if this doesn't look familiar, it should. He liked to use wood. He liked to have floor to ceiling glass. And he obviously liked to have these surrounds on his buildings. So construction was started. This is just the construction sign. It says, this is the best I could find, Lloyd Rocco architect, various other people, construction company. And I couldn't find very many photos of construction. This is just the beginning with somebody digging, running a grader through the canyon to kind of dig it out. This is the same looking up biological grade before, and this is looking up biological grade once they started. So the first step was to take this canyon and dig it out and push the dirt down the canyon, down the hill to build up what was a canyon that went down to the ocean. And so I think we could describe the building construction in the following steps. Widen the canyon in both directions, make it longer, make it wider. Then put a building where you've just dug it out. Okay, this is now the lower part of IGPP. Put some foundations on the two sides of the canyon, build a bridge, and put the rest of the building on top of the bridge. And so if you look underneath in the service yard, you will see some rather massive girders, and that's the bridge. So as I say, it's kind of it is to me a very unusual construction where it's been stacked, but it's been done in a way that I think conformed to the landscape very efficiently, right? Made use of the fact that there was a canyon with space on either side. The final cost was not that high. In 2015 dollars, it was $160 per square foot, which is still spectacularly low. Now, whether intentionally or not, Walter and Judy followed a maxim which I once heard from my parents, which is, if you plan a major project on your house, one of the things you should budget in is a trip to Europe for the duration, so that you will not be tempted to be around and tell the architect that you want to make changes. In this case, Walter and Judy went to Samoa for Walter's Waves Across the Pacific project. So they were actually not around when the building was built. And this may have helped keep the cost down. So here it is, brand new. In fact, so brand new, I don't think it was quite finished. And there's a photo. Once it was finished, it looks remarkably stark without any landscaping. But it's, basically the same thing we now know. Again, here's, think a building, a canyon, and a bridge. I will admit, I had never thought of this as how to look at the construction of IGPP until I first gave this talk. And again, this is just for comparison. This is the building brand new with the parking lot, which has not changed, including the width of the parking spaces, I think, which is great. There was one feature that was different, and that is the bottom part of the building didn't extend quite as far as it does now, probably not as far as it was originally intended to. And my theory is this is where the 6% came from. Was in order to stay within budget, they simply shortened this, and then later on, funds were found to extend it. So if you're down on the mezzanine level, you can kind of see where the join is between what was originally built and then this extended piece. And again, this is a then and now picture. So this is the reading room before, much was to put in there. And this is the conference room, and called the seminar room. This is if anybody knows, Ansel Adams is a very famous American photographer, and the university hired him to come and make pictures of new university buildings in the 60s. And he really liked IGPP. So he took a number of photos. And so this is an Ansel Adams, you know, this is one of the great photographers in American history taking a picture of a conference room. And there was a fireplace, still there when I came, used once, and it didn't work very well. So it was removed. I think you could still see the hole in the ceiling. But otherwise, pretty much the same thing as now. So, and by the way, I had originally a close-up of what's drawn on the board, but I omitted it partly because it appears to have simply been random stuff drawn for the occasion. Although it does look like marine magnetic anomalies, there's some equations in there that don't make any sense that I could figure out. So another feature, sign of the times, can't help bringing this up, are the ashtrays. Now, originally when I gave this talk, it was in that room, so I could point at the walls and say, there are these curtains. So this is the tablecloth curtains. These were made in Tonga from, I mean, it was something that people in Tonga made. They made this kind of cloth by beating something called the paper mulberry, which is a plant, and putting the bark together to form a sort of a cloth. It wasn't really woven. Marge Bradner, who was the wife of somebody at IGPP, purchased a very large example in 1963. There's a much faded photograph in the conference room, but this is the original. So she bought this whole thing. Interestingly, this was, as far as I can tell, this was unprecedented. People usually showed up and bought, you know, a square for their house that they were going to frame. But for somebody to show up and buy the whole thing was, for the Tongans, quite a novelty. The other artistic feature of the building was, of course, the statue spring stirring. This was done in 1948 by Donald Ford, and purchased for IGPP. Cecil Green, about whom I will say a little more in a minute, asked Walter, "What would you like from me?" And Walter said, "Spring stirring." So they purchased the statue, built and carved a plinth, and this is the plinth, and the statue being installed. Now, the aftermath was that in 1980, at I believe a party for Teddy Bullard, somebody had the bright idea of cooling the champagne by putting dry ice in the pond, and apparently there was a flaw present in the rock, so it cracked. So that's the reason it's in two pieces. So Cecil Green. Cecil was a geophysicist trained at the Colorado School of Mines. And in 1941, he started a company to manufacture and sell geophysical instrumentation. And he liked to tell the story that he incorporated the company, and the next day was Pearl Harbor Day. So the environment he was planning to build for changed, but the company survived. They broadened their activities in the 50s, hired a guy named Jack Kilby, who built the first, what's it called, integrated circuit. And so Texas Instruments, as it was called, was one of the pioneering electronics companies and became a very, very valuable company, and Cecil owned a large fraction of the stock. And his goal in life was to give it all away before he died. But he did not have any children, and he succeeded. So if you look around a lot of places, there is Green Hospital up on the mesa there. There is a Green College at Oxford. There are lots of green buildings, one place or another. There's one at MIT. His main support here initially was for the Green Foundation, which runs the Green Scholars Program to basically to bring in people from the outside. This was something Walter modeled after Teddy Bullard and Mattingly Rise, which had a steady flow of people visiting. And Walter had experienced the value of having a bunch of people come and interact with each other and wanted to replicate that.
So the Green Foundation was set up as an independent entity from the university, which apparently the university really didn't like, in order to fund this. Cecil and Ida provided, his wife provided support for the first IGPP seismic network called Project Ida, which technically stands for International Deployment of Accelerometers, but obviously was to honor Ida Green. He and friends helped pay for helped support land acquisition at Pinion Flat. And eventually, in 1993, he donated considerable funds to build the new building. So he was quite, he and Walter had connected with each other somehow in the probably in the 1950s. And he became a reliable and very thoughtful donor. He was also an incredibly nice man. I knew him, I got to meet him a bit. I think it's a tribute to Walter that this happened. Another geophysicist, Ewing, who ran Columbia, apparently kept trying to get Cecil to give him money, but Cecil didn't like it. He was too aggressive. And so it didn't work. But Walter was charming as he could be, and things worked well. So, some special touches of the building. Room numbers, right? It's a university. All the rooms have to have numbers. I don't think they did when I came. Now they have these little tiny wooden flags that you can't see on the top of the doors. But this was an attempt at informality. One of the features, I didn't put this here, was all the offices were the same size. There was no, here is the person with the big office, and here are the people with the little offices. It was just a long row of offices, all the same size. This is actually, you'll find one other building like this, which is the Institute of Astrophysics at Cambridge, which Fred Hoyle had been a visitor in La Jolla, liked this design so much that he basically just took it back to Cambridge and said, build it like this. So there are two buildings designed that way. Another part of the informality was the nameplates. Irrespective of your rank, with one exception, you were Mr. Munk, you were the director, Mrs. Burbage was a professor, Mr. Agnew was a graduate student, as was Mr. Now, obviously, with time, we got to using Ms. and then went to first name, last name. The only exception when I came was Teddy, who got to be Sir Edward Bullard. Nobody else got their first name on the plaques. Walter also had a tradition of monthly lunches, which were where people would give talks. That was useful, but eventually became, I think, too expensive. Another feature of the building that I didn't mention before and have come to appreciate more and more is the design with the service yard and the very large glass doors. Walter wanted to make it easy to move large items of equipment in and out of the building. And that has paid off many, many times over the years. If you go to any of the older Scripps buildings, you will find it quite difficult to get large items in and out. Just try it in Sverdrup. But IGPP was beautifully designed for that. Another feature was the door photos. So this was Walter's. He wrote to lots of people saying, I have a request, could I have an undignified picture? In this case, of Harold Sverdrup, who was an advisor. I am collecting undignified pictures of great men in geophysics for our new laboratory. So when you look at the door photos in the Munk lab, what you're looking at is supposed to be a collection of undignified photos. He didn't want just the standard, formal picture of someone. And I think that tradition has been kept up pretty well. Okay, but this was all to do science. So what kind of science was done? Well, in 1959, a committee report wrote about the need for fundamental research in seismology, which was viewed as a seriously underfunded field, which could be claimed to be of great national importance because of detecting nuclear explosions. And this argued for putting significantly more money into the field than had previously been done. And The initial hires kind of reflect that focus. We have George Backus, theoretical geophysics, Dick Hallbrick, seismic instrumentation and data analysis, Danny Gilbert, theoretical seismology, Hugh Bradner, seismic instrumentation. And then going on, a couple of oceanographers. Walter, after all, was also an oceanographer and a geophysicist, insofar as there's a distinction, which I think he would have said that was not. Two more people doing seismology, and Bob Parker, another theoretician. And I did sort of talk about this. A major feature of the building was the amount of space given over the lab space. You could move large pieces of equipment in and out. You could build stuff. It was very much a building designed for the creation of equipment. So for example, it had its own carpenter shop and its own machine shop. So if you wanted something built, there was somebody you'd go talk to the machinist and he would build it for you. Originally, two of the labs were Munk and Snodgrass, and now it's Matt Jetsu. Then the Copper had a lab, Hugh Brenner had a lab. Originally, two of the labs were given over to ping pong tables. Not where Vachon has had ping pong tables recently. That's in the extension. The extension was originally the machine shop. So only recently converted into a lab, but there is a history of ping pong tables down on that level. And of course, as the place grew, the labs got filled up with other things, and I'll talk about the growth in a minute. Partly, this is, forgive me the down memory lane part, except this is even before my time. How did people do computing? Because Walter was an early adopter of very intense computer operations. So in 1959, you would send your cards to the Western Data Processing Center at UCLA, which had an IBM 709. They had kind of the only one in Southern California. In 1967, you would send cards to the CDC 3600 on the upper campus, cutting edge, had 100K of memory, 12 tape drives, and a plotter. The plotter is very important. I'll explain why. And Walter and others wrote a collection of programs to process time series, because that's what Walter did a great deal of, and wrote code such that you could quite efficiently, actually, I mean, since it kind of looked like MATLAB does now, with a few lines of code, you could do a great deal. By 1979, we had a computer in the basement. It still had a card reader. Now, this is where I had to get to pass around the item. So Steve Miller kindly provided me with this box, which is the box that you would send to the upper campus to get your cards punched, and they would send it back to you. So I will circulate that with a deck of punch cards inside it. This appears to be my first power spectrum program, at least from the label on the cards. This is, I like to say this dates back to the era when the most important thing in the computer room was the box of rubber bands. If you ran out of rubber bands, everybody got very nervous. So I'll pass this one around. I do not miss this era at all. So this is the cover of FOM, System of Programs for the Analysis of Time Series, by Teddy Bullard, who was also a very early computer user. Florence Alabay, who was Walter's programmer, Walter, and a student of his, Gaylord Miller. And this actually was adopted in a few other places. Okay, something. Whoop. Okay. Another early piece of programming was Bob Parker wrote a program called SuperMap, which would produce maps and various map projections. It had a punch card database of coastlines of the world. And this is an early example. This is a Mercator projection. What's notable about this is, and this was what Scripps one of the few places you could do this, because we had a computer with a plotter. Most places didn't have a plotter. You couldn't draw pictures. So this is the plot showing the Mercator projection of the North Pacific, and if you look carefully here, you will see two arrows indicating these strikes of fault, and another arrow here indicating subduction. And these are the maps that underlay the paper that Bob wrote with Dan McKenzie on tectonics on a sphere, which was the first paper published on plate tectonics. And part of the argument of that paper was if you used the Mercator projection, all the arrows would line up. And that meant the plate had to move as a unit. So this is actually from Dan McKenzie, apparently drawn on October 2nd, 1967.
The first one was by Backus in Nature.
Yes, George Backus published an article about rigid plates and magnetic stripes in nature, which amazingly was ignored by everyone. I mean, he was at Scripps, right? Who pays attention to people at Scripps? Even apparently, not even the people in the office next door. So, and he also requested funding from NSF and was turned down. I've never been able to locate. I would love to find the NSF review document saying, no, we're not going to fund you to investigate this. Okay, so the last time I gave the talk, this is where it ended. And I thought, well, I really should include something about what's happened in the 60 years since this end point. And so this is going to be very superficial. There's, I could give another talk that would be much longer than this about various things that have happened, but there are lots of things that happened that I don't know about, even though I've been here for my entire career. So I'll just talk about, well, I say mention numbers and how these were dealt with. So this gets back to the building issue. This is another photograph from 1960. This is from 1972. And I show it partly to point out that IGPP genuinely was remote from the rest of Scripps. Over here, again, that's the outer part of Scripps. That's the service yard. Next to that is a parking lot where you could park and where people would come and park so they could go to the aquarium, which at that time was down the hill, just public parking. And then here's IGPP, and here's a giant building with an enormous wave tank inside, which was what the hydraulics lab looked like originally. And then further up the hill was parking lots. Well, if you get to parking lots, you know you're on the outskirts. And so IGPP was, in fact, kind of separate from the rest of Scripps physically. And this is, of course, things started to fill in. This is 1989. Now, there's a biology building hubs. There's the Eckert building, which was originally built to be the new Scripps Library until the Scripps Library was merged with the Central Library. This, which I think is now closed, is half of Walter built down the hill from the Keller down to the lower campus. It's now regarded as sufficiently hazardous that people are discouraged from using it. And, but on the other side, over here, there are these white things. These are cottages buildings. So it's basically ice plant, some wooden stairways, and some small buildings, which I would look at and think, boy, these would be great to begin. Well, at the same time, IGPP was growing. So this is a time series plot showing the number of researchers, the number of faculty, the combined total, which is basically the number of people writing proposals, and the number of students. And there are lots of features for this plot. Do not ask me to explain the giant dip in the number of students here. I don't think any of us really understand why that happened. What's notable for this talk is that starting from about 1975 until 1990, there was this continuous growth in the number of PIs. And that meant that the building went from being relatively uncrowded to more and more crowded. Part of this was dealt with by putting the students in various outlying buildings, like the cottages that I just mentioned. And so, solution to this problem was to build a new building. So as it happens, there's a thing called the California Coastline Project, which has photographs of the coastline at different areas, and we happened to capture the construction phase. So this is the Revell buildings under construction over here. And that increased the amount of space by about a factor of 1.5, enabled us to bring the students back into the buildings. And that is pretty much, and there's where we are today. So I will simply flip back and forth. And of course, the bridge here was put in a bit later. So what does this give us for background? Well, what Sverdrup and his teachers have passed to Walter was that you needed to have models and they had to be based on some physics. And you needed to be very respectful of the data. So your job in life, and I would say this is a typical Walter paper, was to take the data set and analyze it very thoroughly in terms of as sophisticated a mathematical model as he could do. From Cambridge, the same tradition, physical models just backed up on math, and a strong tradition of instrument building, which we have retained. We don't have our own machine shop anymore, but we still have people who assemble large items in those labs before taking them into the field. A piece I haven't mentioned is that Walter was very influenced by John Tukey at Bell Labs, and that led him to institute the use of the most advanced methods for data analysis. And some people in this room are taking a course that teaches these things. And underlying all of this, and what's made being here a wonderful time, is there's an overall sense of community. If we work together, we can take a lead in whatever it is we're studying, and we can set an example of how research is done. So thank you. I'm happy to have questions. Bill.
Duncan, your document 3 is the oldest example I've seen of the use of IGPP, because Munk takes that work was published in 1960, and was still IGP then. Did your review of the archives show any memorandums with your?
I could not find that. The rumor that the story I've always heard, and I didn't find anything in the archives one way or the other, was that the planetary part was added to make keep Gordon McDonald here, but he left it.
That same story.
So, but no, I have not found a there's somewhere there must be a document, but probably in the UCLA archives saying we're doing the rename now.
You narrowed the window down very much. Thank you.
As someone who works a lot with the history of science and thinking forward to the next 60 years, where someone else will be giving a similar talk to this about the things that's happening today, what sort of things should we be preserving?
What people like to, I've done some archival work, and the best thing you can find is letters. I think if I had to say what's the absolute minimum, it would be proposals. Because if you want to know what somebody is thinking about what they should do next, what they think is important, you can look at the proposal they've submitted to NSF, and you will know within a couple of weeks that that's when they were thinking about it, because of course they didn't write the proposal until right next to the deadline. So proposals are probably from the sort of just bare history of science thing, the first thing you'd want to have. The next thing after that is probably letters, which now, of course, would mean somehow managing to archive vast quantities of email.
And the other thing, I think it was done once when that thing came, and that was, they sent someone around on a day with a camera. And they knocked down doors, and who was ever opened the door, got the picture to it, and just gave the life. That sort of archiving. I don't know what happened to that, if any of it still exists, but it would be, quite nice to do that.
Yeah, I mean, I mined the photographic archives to the extent I could, and I often wish there were more.
Was there ever a branch of IGPP at Los Alamos when that was partly UC?
Yes, so IGPP, and I was focusing on scripts, so I didn't get into this, but IGPP became what the university called a multi-campus research unit. And it had branches at UCLA, here, Los Alamos, Riverside, and Santa Cruz, not Berkeley. And at some stage, I'm sure John Orcutt remembers, but probably would prefer not to, the university declared they weren't going to have multi-campus research institutes anymore, and so that sort of ended. There was an idea that the different institutes would sort of get together occasionally. That never really worked out that strongly. But there were programs where you could fund some, you could bring somebody from Los Alamos here under that. So there were other branches of IGPP, but I'm being deliberately a bit parochial here.
Your list of early hires here illustrates a point I think is important. Is Walter was not just a theoretician, but he was a big promoter of experimental methods.
Yes,
And the lab down there and many of the people in this room were real beneficiaries.
yes. And as I say, the whole design of the building shows that. There's this gigantic amount of space given over to lab space with a flavor of, building things that would go out into the field. Originally, there were some additional labs. Actually, when I came, some stuff had already left. There had been some fume hoods up on the top floor. So there was some plan to do chemistry, but that seems to have fallen by the wayside very early. But yes, I think one of Walter's memoirs, he says he regrets that he was sheltered from building things as a boy. So he took an interest in doing that.
Is there anywhere like a book where a lot of these stories are written down? Or are you thinking of writing one?
No, and I should. But
Please do.
there's two histories of scripts, one running up to about immediately post World War II, which is quite thorough, and another one by Betty Shore, which is much more of a sort of a catalog, which would contain some of this, but obviously not a lot of the details. At the same time, I feel that I haven't really, to do this right, you'd want to spend some time in the archives at UCLA to get the other end of the story.
Well, we're at the hour now, so maybe we can continue this discussion at tea time, but that was fantastic, Duncan. Thank you so much.